All right, today we're going to talk about one of the most insidious hazards out there in the industrial world. It's a gas, and it's a totally natural part of our planet. But get it in the wrong concentration, and it turns into an absolutely efficient, silent killer. So, let's dive right in.
I mean, just think about that for a second. Your sense of smell, it's one of your most basic primal warning systems, right? It tells you if food has gone bad, if there's smoke. So what happens when the very thing that's trying to kill you is designed to switch off that warning system almost instantly?
Well, the answer is hydrogen sulfide. You'll see it written as H2S. And this stuff, it isn't just a simple poison. It's what's known as a broad-spectrum poison. And that means it can go after a whole bunch of different systems in your body all at the same time. Your breathing, your nervous system, pretty much everything.
So you might be wondering, where does this stuff even come from? And the answer, well, it might actually surprise you. It's way more common than you'd probably guess.
Okay, so H2S is basically a byproduct of stuff decaying. You'll find it anywhere organic matter is breaking down without oxygen. Think swamps, sewers, that kind of thing. And it's a huge hazard in big industries, like oil and gas, mining, shipping. But here's the wild part. Our own bodies actually produce it in super tiny, totally harmless amounts. It's used to help relax our muscles. It's just a perfect example of that old saying, the dose makes the poison.
And like any good villain, this gas has a bunch of aliases. If you ever hear workers talking about sour gas on an oil rig or stink damp down in a mine, yep, they're talking about H2S. And that rotten egg smell, that's its most famous calling card. But, as we're about to find out, it's also its most dangerous trick.
So to really get a handle on the risk here, we've got to look at its rap sheet. What are the specific properties that make this gas so unbelievably dangerous? First up, it's completely invisible. You just can't see it. You could walk right into a thick, lethal cloud of this stuff and have zero visual warning. None. Second, it's heavier than air. Now what that means is it doesn't just float away and disappear. Nope, it sinks. It pools in low-lying areas that don't have good ventilation, places like trenches, pits, cellars, tanks, just sitting there, basically waiting for someone to wander in.
And this is the gas's deadliest trick. See, even at pretty low concentrations, H2S goes right after your olfactory nerve, the nerve that lets you smell. So you might get a whiff of rotten eggs for a second, but then, poof, the smell is gone. But it's not because the gas is gone. It's because your ability to smell it has just been knocked out, paralyzed. And that is exactly why trusting your nose can be a fatal mistake.
And believe me, the list of dangers just keeps on going. It's a powerful neurotoxin. It's super flammable and explosive in the right concentrations. It's so corrosive it can actually make steel brittle and weak. It can dissolve in liquids like oil or water and then, whoosh, get released all at once if that liquid gets stirred up. And if it does catch fire, it burns with this eerie blue flame and produces sulfur dioxide, which is a whole other toxic gas. We're talking about a seriously multi-talented threat here. Okay, so if you can't see it and you can't reliably smell it, how on earth do you know it's there? Well, the answer comes down to technology and a very, very specific way of measuring it. And that unit is called parts per million, or ppm for short. It's just a way of talking about incredibly tiny concentrations of something. To give you an idea, imagine a big kitchen sink filled to the brim with water. Now, picture one single drop of ink in all that water. That's the kind of scale we're talking about with 1 ppm. And understanding this scale is literally a matter of life and death. It is so important not to confuse parts per million with percent. 1 ppm, like we said, is a tiny, tiny amount. But 1%, which, sounds pretty small, is actually equal to 10,000 ppm. That's a concentration that can knock you out and kill you almost instantly. The difference is huge. Let's just walk through how quickly this escalates, okay? At just 0.13 ppm, you might just barely notice that rotten egg smell. At 10 ppm, which is the legal limit for short-term exposure, your eyes start to get irritated. Now jump up to 100 ppm. At that point, your sense of smell is gone in just a couple of minutes. By 500 to 700 ppm, you can lose consciousness and die within an hour. And if you get to anything over 1,000 ppm, it's lights out. Immediately. Unconsciousness is instant, and death follows within minutes. It's that fast. So, what's actually happening here? How does it kill you? Well, the H2S gets into your bloodstream through your lungs, and it just overwhelms your body's ability to process it. It travels straight to your brain, and it paralyzes the very nerve center that controls your breathing. It basically tells your lungs to stop.
So your lungs just stop working, and you suffocate even when you're surrounded by perfectly good air. Now, I know this all sounds absolutely terrifying, and frankly, it is. But for the thousands of people who have to work around H2S every single day, it's actually a manageable risk. So how do they do it? Well, it's all about a combination of technology, a ton of training, and really strict procedures.
The number one rule of H2S safety is this: you absolutely do not trust your senses. You trust your equipment, period. Every single worker in an area with potential H2S wears a personal monitor that'll scream if it detects anything. Teams use portable ones to spot check areas, and they have fixed monitors that are just constantly sniffing the air in one location. These gadgets are basically an electronic nose that can't be paralyzed.
And when one of those alarms goes off, the training just kicks in. There's no thinking, no hesitation. The response is immediate. It's automatic. Step 1, get on air. You grab your emergency breathing gear and you put it on, now. Step 2, warn everybody else by hitting a general alarm. Step 3, you get to a safe area, usually upwind, at what's called a muster point, so everyone can be accounted for.
Now, you should know not all breathing gear is created equal. You've got your EBA, that's an emergency escape breathing apparatus. It's just a small bottle with maybe 10-15 minutes of air. Its one and only job is to give you enough time to escape the danger zone. But then you have the SCBA, the self-contained breathing apparatus. That's the big setup you see firefighters wearing. It's a much larger setup, and it's used by the response teams to go into the hazardous area, either to rescue someone or to fix the problem.
And here's a small detail that can literally be the difference between life and death. That face mask, it has to form a perfect seal against your skin. Any little gap, and I mean even the gap caused by a little bit of stubble, can let that toxic gas leak right in, making the mask completely useless. It's why, in these industries, being clean-shaven isn't just about looking neat, it's a critical, non-negotiable safety rule. So once all the workers are safe and accounted for, that's when the highly trained emergency response team suits up and goes to work. Their job is to put on those big SCBA units, go into the hot zone, find the source of the leak, rescue anyone who's down, and get the system safely shut down. Only after they've confirmed the area is totally clear can anyone else go back in. So when you look at the whole picture, yes, H2S is a formidable natural threat, but it's also one that we know how to manage. It's that combination of understanding the danger, using the right tech to see the invisible, and having rock-solid procedures that everyone has practiced. That's what turns this silent killer into a risk that can be controlled.
And really, it leaves you with a final thought, doesn't it? The story of H2S is such a powerful lesson in being aware and prepared for a danger you literally cannot see or smell coming. It kind of makes you wonder, what other invisible dangers are we overlooking in our own lives? Whether they're physical, financial, whatever, what are we not preparing for just because it's not immediately obvious?
It's definitely something to think about. Thanks so much for watching.